Hi everybody. Today we're going to look at 5.7 and 5.9 in the module and CK12 assignments, and we're going to find the equation of a line in slope-intercept form. From Algebra 1, you may or may not remember that slope-intercept form is y equals mx plus b. Let's take a minute to explore this in case you're of the I don't quite remember that category. So I'm going to look at this y equals mx plus b. Y equals 2x plus 3, an actual equation of a line. And I'm going to plug in some values. So I'm going to say when x equals 2, or sorry, negative 2, that this is 2 times negative 2, right? Instead of 2x, I got 2 times negative 2 plus 3. And that, when I multiply, I get negative 4 plus 3, that's negative 1. And what we just found was an ordered pair on our line. When we plugged in a negative 2 for x, we got a negative 1 for y. And I can plot that. Origin, negative 2, down 1. There we go. Point on our graph. And we can plug in a negative 1 in the same way. Y equals 2 times whatever we plug in for x plus 3. Multiplication, then addition, and we found another ordered pair. You should pause me and try these. Make sure you get the right ordered pairs. If you don't, you'll hear me blab through it, right? Y equals 2 times our x plus 3, another ordered pair. Two times our x plus 3, and we have another ordered pair. Plug in an x, get out this y. And I'm going to plot all those points. Negative 1, 1, 0, 1, 2, 3, 1, 5. All right. And we can connect the dots. I can certainly see that's linear. We thought this was going to be a line because it's in y equals mx plus b, and that's supposed to be an equation of a line. So that's good news. If not, I would have checked my table. I probably did some adding wrong. And then we can see if we look at this, I don't care which 2 points you use, but I'm just going to pick these two. The rise is 2, the run is 1. So the slope is 2 over 1, otherwise known as 2. And if I look at any of these, up 2 over 1, up 2 over, the slope is the same. We expect that because it's a line, should have a constant slope. And now I just have to look for the y-intercept. That's the point where the line smacks into this y-axis, and I can see it. I'm looking at it. And that point was the point over here, right? It was the point 0, 3. And you could say the y-intercept is 3, or you could say it's the point 0, 3. I believe CK12 goes through both of those. So you should be familiar with it written in point form, where x is 0, or if they just ask you for the y-intercept and you get the number. They'll specify in the directions. Okay. So what we notice is we found the slope of 2 and the y-intercept of 3, and that's really interesting because, I mean, we did all this work, folks, and look, everything we needed was right there. We just had to know where to look. The slope is sitting right there hanging out with the x. That's our letter M they used to stand for that slope-intercept form. And the 3, the positive 3, is also staring right at us. That's our y-intercept. And they call that B in the formula, right here. But if you know where to find the stuff, look at all the work you can just skip, right? Mathematicians, we are inherently lazy. I like to call it efficient, but sometimes people do call me lazy. So if we know where to look, we don't have to, to do all the work. So that's why y equals mx plus b is called slope-intercept form. Because if you know what you're looking for, the slope is always there, the y-intercept is always there, you've got no work to do. Okay, so let's just try a couple here. Looking at this one, pause me and see if you can pick out what the b is and what the m is. Okay, we said our m always hangs out with x, and our b is the number by itself, the constant. So it looks like b is 1 and m is 4. Remember, B is actually a point on the graph. It's the slope-intercept. It's the point where this graph smacks into the y-axis. So if I wanted to write it as a point, 0, 1 would be the point. And I'm going to graph it, 0, 1. And now the slope, that isn't another point on our graph. That just tells us how to get to another point. It's rise over run. Now, I don't have a denominator, so I think we get used to that idea of making that 4 is the same as 4 divided by 1. So we could put that denominator there. And now I know just how to count from the 1 point I know. I'm going to go rise positive 4, 1, 2, 3, 4, and a run of positive 1. And we've got the line graphed and very pretty and easily done. All right, let's look at one more of these and see if you can do this one on your own. Hit pause and go for it. The 1 point we know is the 0. This is the y-axis. Negative 3. We go there. And then the slope is up 1 over 2. Once you have 2 points, you are in absolutely perfect shape for graphing a nice graph very easily without a lot of work. Just have to know where to find what you're looking for. Slope, y-intercept. Okay, let's take a peek at just a few more of these. Short-term memory check. Find the equation of the line in slope-intercept form, which looks like, you ready? Y, write it before I can. Y equals, faster, faster. There we go. Y equals mx plus b, so you don't forget it. And let's just see. They've given us the slope and the y-intercept, so we should be able to fill in the blanks. That's all it's asking you for. And there's some CK12 questions. That's all they're doing. Y equals. Now think about what is going to go in for the slope here. Let me see if I can get this not to be quite so exposed. If I can get it to focus a bit. Okay, a little better. Okay, so what's going to go in for the m in our slope-intercept form? Plug it in. And what's going to go in for the b? The b is a minus 3, so we should put minus 3. All right, and that's it. Now take a look at your work. Let's critique ourselves. If you did not write the x, go back and write the x. Remember, the slope is hanging out with the x. The x is just a number we can plug in for xy point on the graph. Okay, so you've got to have that x there. All right, try this one. Y-intercept is 5. See how easy that is if they give them to you. And then the last one, let's just go ahead and find the y-intercept equation of the line that's drawn. So you're not just going to be told what the slope is or what the y-intercept is. You have to find it from a graph. So let's see. This is our y-axis. So take a guess. That y-intercept looks like it's right here. 1, 2, 3, 4. Or you could use the point 0, 4. And the slope is how to get from one point to another. The rise is 2, and the run is 1, 2, 3, 4, 5, 6. And you could note that you're doing that to the left, so it should be a negative 6, or you could do what I do and just do rise over run, and because it's going downhill from left to right, you can throw the negative in there. So it doesn't matter to me if you count with the negative or you just look at it, and that's what you end up with. And this is going to reduce to, so our equation, we've got our slope and our y-intercept, looks like y equals mx, don't forget it, plus 4. And that is our slope-intercept equation of that line. Thanks, folks.